تفضل.
السلام عليكم ورحمة الله. And thank you for joining us today. My name is Abdulmajid Ahmed. Allow me before we start to thank the electric department on behalf of the team and thank our supervisor, Dr. Abdullah Qusayr, for his help and guidance to the team through the term. Today we have the senior design project presentation, traffic sign detection based on sound systems. This presentation is divided into four different sections. The first is the introduction, methodology, design process, and finally a conclusion. In the introduction, we will go over the problem, a background review, the proposed solution, and the objectives. The high increase in using autonomous vehicle requires the vehicle to be aware of the surroundings. This awareness can be achieved by using visual sensors. This approach, using visual sensor, can have its own limitations and problems. In this project, we will implement and design an approach will overcome these limitations. But before that, what actually the problems with using traditional sensors? As you can see in these figures, we have corrupted road signs. The vehicle will not be able to detect these road signs due to weather-related problems or accidents. Second, image processing requires high computational power, and it's costly to implement. Also, when using the cloud to process data, the latency could be a problem. Our approach will overcome these limitations. And now a background review about what VX mean and other approaches used with the vehicles today. VX, V to the X communication means the communication of the vehicle with the environment. The vehicle can exchange data and information with other vehicles or pedestrians or even infrastructure. Infrastructure like traffic lights or road signs. A lot of approaches used to enable the vehicle to interact with the infrastructure. We have, besides image processing, we have radar systems. Radar systems, the vehicle use radio waves to detect objects around the vehicle and to gather information. The radar systems, same as radar, but it uses a laser light to measure the data. Our approach will work with these systems to assure a good experience for the users. And now for the proposed solution.
In this project, a new idea is proposed which employs the usage of road bumps and Morse code to deliver information to the vehicle using the sound waves produced by these road bumps. The system will include three modules: a sound decoding module, a transmission module, and a signal processing module. First, here are the objectives of our project. First is to define the problem and propose a solution. Second is to set up an initial plan for the proposed solution. Third is to design a flowchart detailing the process step by step. Fourth and fifth is to apply source coding concept and channel coding concept. Sixth is to choose a specific type of road bumps for our project. In the seventh point, in STB2, we will simulate the process and implement it on a microprocessor, then finally test it in real life scenarios. Next up. Next up, methodology. In methodology, we will have two main topics. First is Morse code, and second is the process. What is Morse code? Morse code is a system of communication that consists of a combination of two symbols, a dot and a dash. A combination of these two symbols can be used to represent many different forms of data, like what is shown now on the picture, which is very similar to binary code. A dot can be used as a 0 and 1 can be used as a dash. Morse code was mainly used before to transmit information over long distances by using light or electricity. In our project, we will have two types of road bumps: a short road bump, which will be represented by a dot, and a long road bump, which will be represented by a dash. Each sign will have its own unique combination of these two road bumps. And each combination will produce a unique sound when a car goes over it. So we will record the sounds of these combinations and save them in a database. So in the database, we will have all the traffic signs, and each traffic sign will have its corresponding combination of road bumps and the sound produced by this combination. In the process, as you can see here, there's a traffic light, there's a traffic sign, and in front of the traffic sign, a combination of road bump representing this traffic sign. The car will have a microphone placed outside it, and it will record the sound produced by the road bumps. After the sound is recorded, it will be transmitted inside the vehicle and then processed by a mini computer or a microprocessor. In the processing, the sound recorded will be correlated with the sounds we have saved in the database. The highest matching sound will be selected and its corresponding sign will be displayed. So as you can see here, here is a traffic sign, and in front of it is a combination of road bumps representing this traffic sign, which is a dash, dot, dot, dash. And here my colleague Tamim.
Assalamu alaikum. So in the design, in the process phase, we are planning to use the correlation function in which we are planning to use the correlation function which is used to measure the similarity between two signals, or another way it is used to detect the presence of known signal in unknown signal. As shown here in the flow chart, which is when the device is on, the mic will keep recording and correlating the sound noise, the recorded sound noise with the bump noise, and then it will check its value. This will act as a trigger for the process because we don't want the process to start from any other noise except the bump noise, and we will check the correlation value. If it is exceed the threshold or not. If not, the process will start from the beginning and nothing happened. If yes, it means the mic capture the bump noise, and it will record the upcoming second and take the recorded signal to correlate it with the sound that are saved in the database. And then we will check the correlation values. There are maybe one or several sound exceeded the threshold. And we will select the highest value among them. We will select the highest value among them because the highest value represents the sound that is the highest value represents the sound that is similar to the recorded signal. Then we will display the output sign based on the sound signal. And now in the design process, my colleague Khalid will continue.
السلام عليكم ورحمة الله وبركاته. طالب خالد رميح. In the design process, we are interested in road bump designing. There are a few factors that we'll take into our consideration while designing the road bumps. The first factor is the efficiency of data compression, or the efficient representation of each traffic signs by adopting the concept of Hoffman technique, and then minimizing the probability of wrong detection by adopting the concept of the channel coding. And the third one is to overcome real-life problem or real-life situation while designing the road bumps. So First, in order to apply Hoffman coding, we need to collect information about each traffic signs. So we scan the map of Radio City and we locate each traffic signs. We have set a limitation and assumption to our calculation. We have get the probability of each sign as shown here. After getting the probability, now we can continue with the Hoffman coding procedures. As I said, we need to have an efficient representation of each traffic signs by using Hoffman coding. Hoffman coding is data compression technique that has several advantages, like high data compression ratio, and it's easy to implement. This diagram shows This diagram shows the procedures of Hoffman coding, and then after applying the procedures of Hoffman coding, we will have a binary code representing each traffic sign. As we can see here, Hoffman coding is a variable code length, which mean the frequent symbols will give them fewer number of bits, and the rare symbol will give them more number of bits. Then we will use a Morse code to assign a dot for a 0 binary, and we'll assign a dash for the 1 binary. Also, we have calculated the efficiency of data compression by using this formula. We have get that the efficiency of data compression is equal 97.38%, which is great. Channel coding. We have adopted the concept of the channel coding by adding a redundant bit to the existing code word. So, by adding a redundant bit to the existing code word, we can minimize the probability of wrong detection. By adding another bit, we will add another bumps to our system. To summarize what we have done until here, first we have generated a binary code representing each bump, and then we have minimized the probability of wrong detection by using the concept of the channel coding. Now Tim will follow up.
See?
The designing process, designing the road bump is important for us, and it plays a critical role in our system. The road bump should be able to generate a specific sound and pattern that can be easily to identify. There are some considerations that need to be taken care of, such as the spacing and the size of the road bump. We need to choose a proper size of the road bump so that they can generate a dash and a dot sound. Also, we need to choose a proper we need to choose the spacing between the road bump properly so that to control the width of the so that we need the space between them should be suitable enough so that the system can identify them and avoid any interference. Also, there are some other considerations like the durability and the safety and the cost of the bump. There are some types of the road bump, which first with proper speed bump, they are commonly used in the residential road. Also, they have a disadvantage, which is they are impractical in high speed because they can cause a damage to the vehicle when they pass over them at high speed. The second type is the asphalt speed bump, which is also very common. But they are less durable, which means they can be broken or cracked or deformed over the time. Also, they can be less slip resistant, which means they can be slippy at certain conditions like weather, like rainy weather, and they are impractical in high speed. The next type is the cat's eyes, which they are costly when compared to the other types. Also, they can be damaged from the vehicle or from weather condition, or they can be removed. Finally, with the rumble strips. Rumble strips is commonly used on the sides of the highways. They are mainly used to generate a loud noise so that they alert the drivers. So they cause a loud noise. So we can take this point as an advantage for our process, and we believe the rumble strip is the best option for us. Also, due to these features, which are customizable, which means we can control the width of the bump. And also, they are cost effective when compared to the other types, and they are durable, which means they can stand high weather conditions. Until now, we have completed the first phase of our project. We have defined the problem and set up an initial plan for a proposed solution. Also, we designed a flowchart that explains the process step by step, and we apply source coding and channel coding concepts, and we compare between the road bump and choose the best option for us. For future work, we have a strategy in which we will discuss the details and technical aspects of bringing our idea to life. This will include 3 main steps, which they are design and simulation, hardware implementation, and testing. And my colleague, Omar, will continue.
So first, in design and simulation, the simulation process will be made as a starting point for STD2 for technical journey. There are many options of softwares and programming language to use in the simulation, but we plan to choose MATLAB for 2 main reasons. First, it has all the necessary tools we need, such as audio recording and correlation function. The second, we are most familiar with MATLAB, and we have most experience with this. In hardware implementations, the code that we have made in the first step will be implemented on a microprocessor. There are many options of microprocessors, such as Arduino, Raspberry Pi, etc. We will investigate them technically and financially and choose the best option for our project. The final step, testing. The hardware will be tested in real-life scenarios, and so we can observe and see what can hinder its functionality and effectiveness. So then we can overcome it and solve these issues. This is just the beginning for technical journey in STD2. And what we have outlined here represent the foundation of our This is just the beginning. This is just the beginning for technical journey of our project. And what we have outlined here represents the foundation of STD2, in which we will investigate how we can This is just the beginning of our technical journey of our project. What we have outlined in this chapter will form the foundation for our work in STD2, in which we'll continue to test and refine our system to ensure its reliability and effectiveness in real-life scenarios. We look forward to share our progress in STD2 with you, inshallah. Any questions? في تعديل بعد؟
بلغت عن النجد هناك عشان بنهاية
سلايد دي بنقل فوق.
وين؟
عشان نصير قريبين.
هم نقعدهم هم هنا.
ها؟
هم نقعدهم هم هنا، أو عندنا ندرس هنا.
وش قصدي؟
هذه
ما فكرت أنا مرة قاعد هنا.
نتكلم عن الكومبينيشن.
هنا على الكوميونيكيشن.
ثم ادخل
عشان بنهاية
عشان يصير هذه
البرزنتيشن
اصلا بداية الكومبينيشن.
أصلاً هي تبي
مش فكرة لك.
لا تبي تستجيب كيف هاد.
واضح؟ إن شاء الله.